Here's example number 3, and it's a trig example, everybody's favorite. So the question is, they give this derivative, and they're asking where the original function h is increasing on this specific interval. And as usual, they give a specific interval for a trig function. Otherwise, you might get thousands, infinite number of answers. So here we go. Proceed just like normal. First, find the critical numbers. That's where the derivative is equal to 0. So we're going to solve this equation. 8 cosine of x be equal to 4. So cosine of x is equal to 4 over 8, or 1/2. So that's where the critical numbers occur. So now we need to figure out x, or those angles where cosine equals 1/2. So I'm going to refer to my unit circle. I remember that cosine's 1/2, positive 1/2, about right here, because cosine's x. So it will refer to this angle and this angle. I'm going to lightly draw in my other angles of the pi over 6 circle just for counting purposes. And now figure out what these angles are. So this angle is 2 pi over 6, or pi over 3. The next angle is 3, 4, 5, 6, 7, 8, 9, 10 pi over 6, which is 5 pi over 3. So the solutions to this equation, or the critical numbers, are x equals pi over 3, and x equals 5 pi over 3. So now, as usual, I'm going to set up my chart. Now, this is a little bit different because we are given a interval. Starting at 0, we're ending at 2 pi, and our critical numbers are pi over 3 and 5 pi over 3. So first I have to figure out a test number between 0 and pi over 3 to plug into the derivative. So if you look at the unit circle, here's 0 and here's pi over 3. I can use any angle between those. I could choose to use pi over 6, but it would be easier to use 0. And since 0 is not a critical number, even though it's not technically in the interval, but since it's not a critical number, you can still use it. So when I plug in 0 to the derivative, remember this is the derivative right here, I'll get 8 times the cosine of 0, and cosine of 0 is 1, so 8 minus 4, which is positive. So we know we're increasing on the interval. From pi over 3 to 5 pi over 3, if you look to the unit circle, that's anywhere from here to here. So you can use any one of these angles in here. I'm going to use this one because it's easiest. The derivative at pi. Again, plug it in here, and you'll get 8 times the cosine of pi. Cosine of pi, x is -1, so cosine of pi is -1. So we have a -8 minus 4, which is obviously negative. So we're decreasing there. And finally, the last interval from 5 pi over 3 to 2 pi. So that's this part of the circle. Just like before, I can use 2 pi because it's not a critical number. And the benefit of using 2 pi is because it's the exact same position as 0, which was there, which we already did, so you don't have to do any work. That's also going to be positive. So we're done with the chart. Now we answer the question. I forgot what the question is, but the chart will give us the answer regardless. We have to figure out what intervals that function is increasing. So looking to my chart, those are the two intervals. So my final answer is it's increasing. Now be careful here. Don't put negative infinity to pi over 3 because we're not starting at negative infinity, and that would not be true. It's increasing from 0 to pi over 3, and then also from 5 pi over 3 to 2 pi. And that is it. Pretty simple.